David Smith here with yet one more flipped classroom math lesson. 3 tips before we start. First, remember that you can slow down or speed up the playback to suit your needs. Second, you can pause the video at any point to catch up with your notes or jot down questions. Third, you can turn on the captions and read my words on the screen. Today's lesson is the sine rule. Now this formula, this rule, works on non-right triangles. Okay, so unlike using sine, cosine, and tangent to find sides and angles of triangles in SOHCAHTOA trigonometry, this rule and the next one we're going to get allow you to use, in this case, the sine function on a triangle that does not have a right angle. Notice this triangle, no 90-degree angle there, but nonetheless, we can use the sine rule to analyze this, find sides. So let's take a look at our diagram. Big A, B, and C designate the corners or vertices of the triangle, and then little a, b, and c designate the lengths of the sides of this same triangle. And then super important, little a, side length, is across big A, angle measure. Little c across big C, little b across from big B. It has to be this way. You want to be able to generate this diagram on paper whenever you need it. Okay, so the rule is pretty straightforward. It's just a series of ratios that are equal to each other. So little a, side length, over sine of big A, the angle that's across from it, is the same as little b across from sine B, as little c across sine C. So another way to say that is the ratio of the side length over the opposite angle, over the sine of the opposite angle, equals the ratio of the side length over the sine of the opposite angle, equals the ratio of the side length across the sine of the opposite angle. This is the sine rule, okay? Now, you can take these ratios and flip them, and it works. Okay, so if you want to do it the other way, sometimes depending on the values that you have, it might make more sense to run it this way. Either way works just fine. Our textbook uses this, but this is equally valid. Okay, let's do a problem. Here's the setup. Triangle PQR shown there. I've got 2 angles that I know, and here's a side length that I know. And I'm going to ask you to find this side length. So this is the most straightforward application of the sine rule. Let's put that up here. A over sine A equals B over sine B equals C over sine C. I think probably now you should even have that rule memorized. It's really simple. All right, so let's take a look at this triangle. All I need to do is write my ratios using what I know and what I need to know. So let's start with what I need to know. This side, x, over sine 113. So that's my first ratio. This side over the sine of the opposite angle is going to equal. Now, what else am I going to use? I don't know this side and I don't know this angle, so that's not going to help me. But fortunately, I do know this side and I do know that angle, so that's going to equal 18 over the sine of 41. Now, my preferred way to do these problems is to then simplify before I start pumping things into my calculator. So what I can do is I can cross multiply up, but leave the x here. So this is going to be x equals 18 times the sine of 113 over the sine of 41. Now this is the best way to do this problem on paper, because now I've isolated x on one side. Now I can get out my calculator and I can do this calculation in one step without writing down anything in between, which means I'm not going to round until the very end. Okay, so I got out my calculator. Here we go. 18 times 113 sine, that equals, now I'm going to divide by 41 sine, and I'm going to get 25.3. So x equals 25.3. Okay, let's do the plug-in step first. It's going to be x over sine 28. That's this side over the sine of its opposite angle. That's going to equal 115 over sine 92. Okay, now just like that last one, I'm going to cross multiply it up with my sine 28 and get x equals 115 times sine 28 all over sine 92. And now I can get out my handy-dandy calculator and do the math. So 115 times 28 sine, that equals, and then divided by 92 sine. And that's going to give me 54.02. So I'm just going to round that to 54.0. And here's why I did it that way. I'm showing the 0.0. That tells you that I rounded. If I just wrote 54, the implication there is that it comes out exactly as 54. And the truth is it's not. It's 54.02. So I want to round to the nearest tenth, so I round it to 0, but I show that that's a clue that this number is rounded. It's an approximation. Okay, here's another one to try. Triangle drawn like that. You're given that side. You're asked to find x. Go ahead and pause the video and see what you get. Okay, let's do our plug-in step. X over the sine of the opposite angle. So we got x over sine 32, and that's going to equal 483 over the sine of 105. I'm going to cross multiply up and get x equals 4, oops, I wrote 2 there. I meant 3 from there. 483 times the sine of 32 all over the sine of 105. So now I'm ready for my calculator step. 483 times 32 sine equals, divided by 105, sine equals 264.97. So this is going to round up to 265. 265. But again, I'm going to do my 0.0 because that tells you that this one was also rounded. It was 64.97, so that 7 rounded the 9 to a 0. So that tells you that that's also an approximation. Okay, let's do one last example. This one definitely tougher than the previous ones we did. So take a look at our triangle. 91 is this side, 65 is this angle, and I want you to find x. So take a look at the diagram. These two little tick marks means these two sides are equal, and that's essential information that you need to solve this problem. So think about that for a minute. See if you can come up with the plug-in step. There's more info you need to throw on this diagram before you do that. Okay, let's see how you did. If these two sides are equal, then this side is also 91. Okay? Now, the thing about isosceles triangles, when you have two equal sides, the angles opposite the equal sides are also equal. So that's 65. Okay? Now, I need this angle because I'm going to set up my ratio with this side over this angle. And it's not drawn on the diagram. However, we can get it. Do you know how to do that? Check it out. Triangles have 180 degrees total. 65 plus 65 is 130. So 130 are accounted for right there. That leaves only 50 left for the top angle. So that's 50. Now you have enough information for a plug-in step that will allow you to solve for x. So if you haven't already done that, go ahead and pause the video and write that step. Finish the problem if you'd like. Okay, let's see how you did. So here's my unknown, and there's its opposite angle. So this is going to be x over sine 50. Now I can use either of the other two. They're going to be the same ratio. It's going to be 91 over sine 65 or 91 over sine 65. Either one's going to work. So I'm going to write 91 over sine 65. So there we go. There's our plug-in step. Now I'm going to cross multiply up and get x equals 91 times sine 50 over sine 65. Get out my handy-dandy calculator and let's do the math. 91 times 50 sine equals, now divide that result by 65 sine, and that gets me 76.9. So that side is 76.9 long. Now that you've watched the video, jot down some notes or questions for our next class. You can also re-watch the portions of the video that you didn't understand so well the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.